In this section, we're going to solve radical equations. So a radical equation is one where you have a variable in the radicand. And since they're equations, we're going to be trying to solve for the variable. So you'd have something like the square root of x plus 2 equals 5, or something like that. And you're going to try to solve for x. So the thing is, how do you, take care of that square root? Okay, so a reminder. If you have the nth root of a, and then you're going to raise it to the nth power, that's going to just equal a for any a greater than or equal to 0. Okay, so now here comes an example. And I'm going to try to give you the steps over on the right. So the first thing you do when you have an equation with a radical, and it's got the variable under the radical sign, you have to isolate the radical. So that's step 1. Isolate radical. So I'm going to add 5 to both sides. So now I'm going to have the square root of 3m plus 2 equals 5. So I'm just putting that over on the other side, and it's going to become a positive 5. Now you have to be really careful when you draw your square root signs or any radical sign that you put it over exactly what you mean for the radicand. See, if I had extended that line too far over the -5, that would be a different problem. Okay, so this is the problem we have. Okay, next, you want to raise both sides to some power, some exponent. And it's going to go by the index that you have on your radical. So if you have a square root, you're going to square both sides. If you have a cube root, you're going to cube both sides. If you have a fourth root, you're going to raise both sides to the 4th power. Okay, so I'm going to rewrite this. You don't have to. A lot of times we don't rewrite it, but I'll do it this time so you can see what's going on. And what you're going to do, since you have a square root, you're going to square both sides. Oops. So it's just like, how you add something to both sides or you subtract something from both sides, but now we're going to square both sides. And squaring is a function, so we're applying that exponent to both sides. We're not multiplying by 2, we're applying a function. Okay, and it's the square function. On the left-hand side then, you have this square root, but since you have the square, that goes back to that reminder I just did a minute ago. So we just have the 3m plus 2. On the other side, on the right-hand side, we have 5 squared, which is 25. Okay, so think about it for a minute. You have a square root of 3m plus 2, but you're going to apply the square on it. So the square root, the square, they like undo each other. They're inverse operations, so, or inverse functions. And it just gives us this radicand then underneath. That's how you get rid of that radical sign. Okay, now I just have a regular linear equation. Now they aren't always linear, but this one is. So solve the equation. That's step 3. So since it's linear, we're just going to get m by itself, subtract 2 from both sides, and then divide by 3. Okay, so we've solved it, and we think our answer is 23 over 3. Now, the thing that you have to do when you have these problems, you have to check them. So it's not an option. You have to check answers. And sometimes you get more than one answer, so I'll put answer or answers. Okay, so now here comes the check. When we check, we go to the original equation that we had. So it was the square root of 3m plus 2 minus 5. Does that equal 0? And now we're going to put in our answer, which is 23 over 3 plus 2. And the 3's cancel, so you have 23 plus 2 minus 5. Does that equal 0? Notice that I'm not putting that 5 under the square root sign because it's not supposed to be under there. Okay, so the 23 plus 2 is 25. Square root of 25 is 5. And 5 minus 5 is 0. So yes, it checks. All right, so I'm going to write my answer. I got an answer. I checked my answer. It works. So the answer is, I'm going to put it in set notation, 23 over 3. Now you might be asking, well, what if it didn't work? Then we would put no solution. Okay, so that's our first one, and we'll do more.